Welcome to this how-to instructional video on how to install wireless remote antennas and grounding. In this video, we are going to cover planning the installation, demonstrate installation procedures, and then give installation examples. Wireless devices and gateways have multiple antenna options since antennas need to be above and away from structures for maximum effectiveness. Examples of integral antennas are on the left. Examples of remote antennas, which this video covers, are on the right. The difference in these examples are the number and length of coax cables and the gain of the antenna. The first thing we need to look at is what is in the box when a remote antenna arrives and what tools you will need to install the antenna. Remote antenna kits are shipped in their own box, which is separate from the device or gateway it is supposed to be attached to. The pieces will vary slightly based on the option ordered, but every box contains at least one coaxial cable, a lightning arrestor, sheets of connection sealant, an antenna mounting bracket, and an antenna. One thing to note is the antenna gain, as this will become important when determining antenna height. The antenna gain can be found on the label, which is at the base of the antenna. Here are the labels. Here is the 6 dBi antenna label. This antenna has the range and installation requirements of a standard integral antenna. Here is the 8 dBi antenna label. This antenna has a longer range, which means it has to be mounted higher than the standard antenna. The tools you will need for the installation is a pair of channel locks or large pliers, a knife or scissors, an adjustable wrench, and wire crimpers that will handle at least a 6-gauge wire. The antenna. For maximum range, it is important that the antenna be mounted away from any structure or other antennas. It is recommended that the antenna be mounted at the top of the mounting pole or structure so the pole or structure does not interfere with the signal. Device and gateways with integral antennas should be mounted at least 6 feet or 1.8 meters above the surrounding structure. The remote antenna with 6 dBi gain is similar to integral antennas. It is recommended the antenna be mounted at least 6 feet above the structure. The remote antenna with 8 dBi gain should be mounted at least 14 feet or 4.27 meters above structure. And lightning rods need to be higher than any antennas, so the antenna does not become the lightning rod. Of course, there are some exceptions to this rule, so consult your wireless specialist if you have any questions. Now let's take a look at where to put the lightning arrestor based on the installation. Lightning arrestors are important in remote antenna installations as they will shunt electrical transients such as lightning or stray charges in the atmosphere to ground. Here are a number of remote antenna and lightning arrestor installations, which all look very different. The installations on the left are where the gateway is mounted inside a building or an enclosure. The ones on the right are where the gateway or device is outside. 2 general things to note. 1. The lightning arrestor is always mounted outside. This is done to avoid a high voltage discharge indoors. 2. The lightning arrestor is mounted at the device or at the gateway when outside. And of course, it is important that they are all grounded and sealed. Let's talk more about grounding. Proper grounding is important for safety purposes and to ensure a stable system. First, let's take a look at the 1410 wireless gateway grounding. The 1410 is a DIN rail mounted device, and there's a grounding plate on the back of the gateway that will contact the DIN rail, which should be grounded when installed. Ensure the DIN rail is isolated from the case or chassis and wired to an instrument ground. An alternative ground is connecting an instrument ground wire to the middle position of the connector on the front of the 1410. This connection is intended for cable shields, but could be used as a gateway ground if the gateway is mounted in a high vibration area. Now let's look at the 1420. The gateway should be grounded using the external lug or the ground lug on the ground connection in the terminal block area. The lightning arrestor ground wire should be connected to an eyelet provided with the arrestor. Lightning is high frequency. Thus it travels on the skin of the grounding wire, so it requires a large stranded or braided grounding wire. It is recommended that the wire be a minimum of 6 gauge or 4.11 millimeter. In all grounding scenarios, the grounding wire should be as straight as possible to ground and cut to length with no coiling. Now for devices. Metal case wireless devices have to be grounded according to local electrical codes. Grounding can be done by using an optional external ground lug or by using the ground lug inside the power module compartment. Finally, there is a difference as to which ground you should use. The gateway should be connected to a dedicated instrument, or sometimes referred to as a DC ground, as you don't want the gateway subjected to plant noise. And the lightning arrestor should be connected to a normal safety ground. This is a demonstration on installing the antenna. Let's start with the bracket. We need to install it as high as possible on the pole or structure, and then we secure it with the U-bolts, lock washers, and nuts supplied. Next, slide the antenna into the bracket, slide on the antenna lock washer, and then the antenna nut. The antenna nut needs to be tightened securely, as we don't want the antenna to turn when installing the coax. Next, we need to tighten the coax onto the connection hand tight, and then 1/8 more turn to engage the seal inside the coax connector. Now we should support the coax. In this case, we are using a clamp. This is needed as the weight of the coax, or the wind blowing on the coax, or vibration could cause the coax connector joint to fail. The clamp should be tightened down enough to hold the coax, but not so tight it cuts into it. The last thing we need to do is seal all the connections. Take one of the sheets of sealant, slice or cut a strip off, pull one side of the protectant paper off the sealant, align the sealant sticky side toward the base of the antenna, and then start wrapping the sealant around, removing the other protective paper at the same time. And then squeeze the sealant around the base to form a good seal. Apply the sealant the same way on the bottom as you did on the top, and then squeeze it to ensure that there is a good seal around the antenna thread to coax connection joint. The antenna installation is done. This is a demonstration on installing a remote antenna with a bulkhead connection to the gateway. One side of the bulkhead is inside a building or enclosure. The other is outside. The gateway is located inside, the antenna outside. The first thing to do is to crimp the ground wire on the eyelet provided, as it's easier to do this when the eyelet is not installed. Slide the wire into the crimp. It is important you use a crimping tool to ensure the best connection to ground. Now slide the lightning arrestor on. Hand tighten the arrestor, and then using channel locks or large pliers, tighten 1/8 more turn. Now slide the grounding eyelet onto the arrestor, then the lock washer, then the nut and snug it down. Next, attach the coax cable. Hand tighten it, and again tighten 1/8 turn more with an adjustable wrench. The last thing we need to do is to seal the coax connections. Using a knife or scissors, make a slice in a sheet of the sealant. Remove one protective sheet and then align the slice in the sealant with the ground eyelet, and then start wrapping the sealant around the arrestor. Remove the other protective sheet and then finish wrapping the sealant around the arrestor. Finally, give the sealant a good squeeze to ensure it is sealing the two coax connections, the arrestor to bulkhead connector and the antenna coax to the arrestor connector. This is a demonstration on installing a remote antenna on a gateway or device mounted in the field. The first thing to do is to crimp the ground wire on the eyelet provided, as it is easier to do when the eyelet is not installed. Slide the wire and crimp. It is important to use a crimping tool to ensure the best connection to ground. Now slide the lightning arrestor on the gateway or the device. Hand tighten the arrestor and then using channel locks or large pliers, tighten 1/8 turn more. Now slide the grounding eyelet onto the arrestor, then the lock washer, then the nut, and snug it down. Next, attach the antenna coax. Hand tighten it and then tighten 1/8 turn more using an adjustable wrench. The last thing we need to do is to seal the coax connection. Using a knife or scissors, make a slice in the sheet of sealant. Remove one protective sheet and align the slice in the sealant with the ground eyelet, sticky side on the arrestor, and then start wrapping the sealant around the arrestor. Remove the other protective sheet and finish wrapping the sealant around. Finally, give the sealant a good squeeze to ensure it is sealing the two coax connections. Now let's look at a number of installations, each with itemized best practice checklist. This is an example of a 1410 wireless gateway mounted inside a building. Key points to ensure the proper operation of this wireless system are: the antenna is mounted to the correct height above the structure according to its gain and clear of all obstructions. The coax connections have been hand tightened and then tightened 1/8 turn more. The coax is supported. There are no tight bends in the coax. Any excess coax is loosely coiled. There is a drip loop before the bulkhead connection. The lightning arrestor is grounded to a safety ground. The gateway is grounded to a instrument ground. And finally, all coax connections are sealed. This is an example of a 1410 wireless gateway mounted in an enclosure. Key points to ensure the proper operation of this wireless system are: the antenna is mounted to the correct height above the structure according to its gain and clear of all obstructions. The coax connections have been hand tightened and then tightened 1/8 turn more. The coax is supported. There are no tight bends in the coax. Any excess coax is loosely coiled. The lightning arrestor is grounded to a safety ground. The gateway is grounded to an instrument ground. And finally, all coax connections are sealed. This is an example of a 1420 wireless gateway mounted inside the building. Things to note: the antenna is mounted at the top of the pole and away from obstructions. All coax connections were hand tightened and then 1/8 turn more. The coax has support. The lightning arrestor is grounded to a safety ground. The coax has a drip loop before entering the building. There are no tight bends in the coax. Excess coax is loosely stored. The gateway is grounded to an instrument ground. And finally, all outside coax connections are sealed. This is an example of a 1420 wireless gateway mounted outside. Things to note: the antenna is mounted at the top of the pole and away from obstructions. The coax connections were hand tightened and then 1/8 turn more. The coax is supported. The lightning arrestor is mounted at the gateway and is grounded to a safety ground. There are no tight bends in the coax and any excess is stored loosely. The gateway is grounded to an instrument ground. And finally, all coax connections are sealed. Contact your local wireless specialist for further clarification on any of these topics. Use the URL below to view the complete educational services course offering.